Okay, next up is, I know we have a lot of different things to memorize, a lot of different formulas. Here's another. Okay, we want to be able to find the equations of lines. This is one form of the equation of a line. This form is called point slope. Okay, so you have a point, you have a slope. Here in this they call the point x1, y1. They call the slope m. And then they plug into this formula. Y minus y1 equals m times the quantity, parentheses, x minus x1. Okay, so let's take our point from the first example. Let's take what's the first point from the first example? Negative 3, 4. Let's take that point. Negative 3, 4. Okay, and our slope was, on that first one, our slope was negative 3/4? Oh, that's weird. Okay, we have our point, we have our slope. That's all we need to plug into this formula. And we wouldn't have to do anything algebraically afterwards. We'll be done. Y is left as a y. Then we put a minus sign. Then we put a y1. That's the y value from your point. Then we put an equals. Then we put the m. Then we put a set of parentheses. And inside the set of parentheses we put an x. And then from that we subtract the x value from your point, which is a negative 3. And that's an equation of a line. There's nothing wrong. We can leave it just like that. We're going to find out that's not the most desirable equation for the line. We're going to see how to manipulate it. But basically that's it. Rewritten, it's y minus 4 is negative 3/4 x plus 3. That's a terrible plus sign. Okay, and we can leave it like that. Nothing wrong with that. That's the point slope form of the equation. Okay, that's the point slope form of the equation, which we had graphed back here. You only need one point. If you have another point, that's okay. But for this form, you only need one point, and that's enough. And the slope together with that one point is what you use. Questions on that? Good. All right. It's not enough, though. There's another form. The other form is called slope-intercept form. Not as involved as the other one. It has an equation y equals mx plus b, where m is the slope, and then this other word here, intercept, is the other variable b. The y-intercept is 0b. Remember, y-intercept means from last class, it's where the line, or in this case the line, where the function hits the y-axis at. And so 0b is the... So if you knew the intercept and you knew the slope, you just put them together. So let's say we know m is negative 3/2, and the intercept b is, whatever, 6. Then we just put them in as y equals -3/2 x plus 6. And our equation would be done at that point. It's called the slope-intercept form. It looks different than the other one. The other one has a y minus something on the one side, and then it has some parentheses on the other side. Okay, point slope form. Slope-intercept doesn't have that. Slope-intercept, what makes it so distinct is that it's y equals, and then whatever's in front of x is your slope, and then this other number that gets added at the end is the intercept, the place where it hits the y-axis at. We should be able to go back and forth between the two. And so what we're going to do is use algebra to connect them. We're going to go back to the one that we had, use algebra to put it into this other form. So let me do what? Select all of this. No? Yeah? Copy. Go down here. Paste. Ah, didn't get it all. What was it? Y minus 4 is -3 fourths x plus 3, something like that? Was it? Ah, we're good. Okay. That was the point slope form. And now we're going to change it. We're going to convert it into the other form. Slope-intercept. This is the more common form. Y equals mx plus b. We're just going to use algebra to make the connection. Okay. It's going to be a bit messy because of the fractions. In fact, I recommend multiplying everything by the denominator to get rid of those fractions. Nothing wrong with doing the algebraic step of distributing. Nothing wrong with that. But I just want to avoid all fractions. I just have this thing with, I avoid fractions by multiplying by the denominator. I don't like dealing with it. But you got to be careful when you do that, though. When you do that, everything that's there, but you don't want to overdo it, though. So I'm going to times by 4 on both sides. But when it comes to doing it on the other side, I just have to make sure I don't overdo it. When I do it on the right side, I don't want to overdo it. On the left side, definitely, I'm going to get 4y minus 16. On the right-hand side, though, when I multiply by 4, it will accomplish the goal of getting rid of the 4. I don't then, again, multiply the 4 on the inside. It's now gone. And what's left is the -3 and the parentheses inside x plus 3. It accomplishes your goal of now you have no fractions. Everything's on one line, no division bars.
So the -3 doesn't turn into -12?
No. Because we took away the 4 from the denominator. Nothing wrong with leaving it as a -12, but then you have to keep around the 4, and that defeats the purpose. Okay, we're almost there. Remember, the deciding thing that makes slope-intercept work is that it's y equals whatever, some mx plus b. So we know we're done when we can get y equals. Okay, we have 4y minus 16 equals